So, you can't see what I did. There you go. So we were here, okay, we had our function in our calculator, and what we were doing was we started by finding the difference between sine and x, because we observed on the calculator that for some portion of the graph, sine x is equal to x, okay? Then we figured out that sine x minus x is also for some portion of the graph equal to negative x cubed over 6. When we move that over, we get that sine is equal to this. So we followed that same exact pattern until we got it down to that sine x equals the polynomial x minus x cubed over 6 plus x to the 5th over 120 minus x to the 7th over 540. And we estimated, or we were guessing, that it would go 9th, 11th, and 13th. Okay. Did anybody figure out what these numbers represent? How did they relate to their exponents? Did they figure that out? We talked about something when we did ratio test. Special type of number. What's ratio test good for? We're really excited about it. There we go. Okay. So I want you to, what's 3 factorial? 6. Okay. So we know that 3 factorial 6. What's 5 factorial? Put it in your calculator real quick. Do you know where the factorial button is in our calculators? Let's look that up really quick. We won't mess up the graph part by putting that in there. Let's see. 5. And let's see. I'm going to get, the factorial button's probably down here under pi. No, it's not. Where is it? Maybe the button next. Oh, wait. Maybe here. It's next to the G. See the G button? Where it's got the question mark and the exclamation point? We call that a factorial in math. So 120. Ooh, interesting. What's the other one? What was the next one? 7. Let's check and see if 7 worked. Ooh, 540. So look at that pattern. Okay. So we have that this would be plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial plus x to the 9th over what? 9 factorial minus x to the 11th over plus x to the 13th over minus ... Let's get this into our calculator and see how good we are at estimating sine. Okay. See how much of sine we can estimate with that polynomial, because a polynomial is nice because we can plug any number into it. Like we could put a 1 into that and figure out what it is at 1 versus just plugging it into sine. Okay. All right. So I'm going to go back here. I'm going to hit my tab key. Let's see. I'm going back to this line right here. I've already got the 6, the 120, and the 540. I don't really need to put those back in factorials. We know they're factorials, but I'm going to use factorials for the other ones. Okay. So I'm going to go all the way up to 13. So control divide, x to the 9th over 9. And remember, your factorial is right here next to the g factorial. I can kind of cheat because I can just probably type an exclamation point on my keyboard. All right, get all the way up to 13 in there. X to the 11th. Make sure you alternate the signs. All right, once you've got it, hit enter and see how good we did. Okay, I'm going to hit the button. Maybe. Ooh, look at that. Isn't that pretty cool? We've got like 1, 2, 3, almost like four parts of the wave there. Okay. We could do better by doing what? Could I keep going? Do I have to stop at 13? I can add more terms and I'm going to get really much better at finding the estimate of sine. Okay. Let's go back here just to prove this to ourselves that this is working. Our function that we are polynomial sitting in F2, right? So let's evaluate F1, or let's just evaluate sine of 0.5. So we'll make sure you're in radian mode. Okay. So trig sine 0.5. That's what it is. Okay. And let's figure out what it is evaluated our polynomial var. It was an F2 of 0.5. Pretty good, right? That they came out to be exactly the same. So the beauty of what this is called the Taylor-Maclaurin polynomial, and there's a slight difference between the two. We'll get to it eventually here. Is it allows us to create a polynomial that can estimate something that is trig, or something that's like an e, or there's about half a dozen of them. There's 4 of them you have to know for the AP test, and if you just have those ones memorized, life is a lot easier. Okay, so if sine has one of these, cosine must have one, right? But what's the relationship between sine and cosine in calculus? What's that relationship? They have their derivative. What is it? How do I get from sine to cosine? Take the derivative. Okay, let's try taking the derivative of this and see what happens. Okay, so I'm going to call this f of x. All right, you can just watch. You're not writing anything down right now. So we know the derivative of sine is cosine, right? Let's see if we can find the derivative of this polynomial here. Okay, so what's the derivative of x? 1. Perfect. Okay. This guy here, I'm going to use green, is 3 times 2 times 1. I bring that 3 in the front. What happens with the 3's? Cancel. So I get minus x squared over, what's 2 times 1? How would we write that? 2 factorial, right? Okay. All right. Hopefully, I think you could probably guess the pattern right now, right? Okay, I'm going to bring 5 factorial is 5 times 4 times 3 times 2 times 1, right? Bring the 5 in front. Plus x to the what? 4th over 4 factorial. All right. What should the next one be? 6 over 6 factorial. What should the next one be? Over 8 factorial. Let's go like 2 more. So minus x to the over, good, plus x to the over. Okay, here's what I want you to do. You can clear your sine out of your calculator. Let's put this into F1. Let's put this into F2 and see if it's good. Okay. Yeah, take the fly swatter. I'm going to do that too. So you're all doing it with me, but F1 and F2, I'll hit the freeze button so you can still see it up there while I'm typing it in too. Okay. Nope. Hey there. the wrong spot. I'll give you about another minute to type, okay? Once you've typed, hit the button and see how good we did. All right, did we get close? Is it good? That's what I got. Was that a good estimate with the polynomial there? Okay, so that's our little whatchamacallit, our exploration. We could do this for other functions. I'm not going to waste, or I'm not going to use the time to do that because I want to make sure that that's not the button I wanted for sure. I want that. I want that. I was trying to turn off the recording. Just this one and hit stop. Okay. I don't know. Let me double check and see if I put the digital notes